Hi, geometry students. It is Monday, January the 8th. And believe it or not, we are coming to the end of another chapter. And this one was short. It was on various shapes. And so I would encourage you to make sure you have your index cards, make sure you're fresh on what those shapes are and some of the theorems that we learned about them. So we will do 6.4 today. I will do a video lesson on 6.5 tomorrow. We will be together in class on Wednesday and cover 6.6, and we will also do a little review with the chapter test in the book. And then you will have another chapter test to take next Thursday. So I don't think this is going to be a hard one. It's probably going to be more along the line of the amount of points for a quiz, so it won't even be a big chapter test. Then when we get back from winter break, we'll be ready to start a new chapter. So please turn to page 325 in your book. The lesson is 6.4, rhombuses, rectangles, and squares. Things are super easy with this. I don't think you're going to have any problems. So let's take a look at the three definitions that they give us right from the get-go. So a rhombus is not probably a common thing that you talk about and refer to, but you've probably seen it. A rhombus is a parallelogram with four congruent sides, and it could take on the shape of a kite. Notice that the angles are not equal in this, but it does have four congruent sides. So it's probably going to take on more the shape of a diamond or a kite. So think about it in those terms. A rectangle, you've known that since you were little itty bitty in elementary school. A rectangle is a parallelogram. So all of these are parallelograms, which we know have sides that are parallel to each other. A rectangle is a parallelogram with four right angles. It doesn't say anything about the sides. The sides are not all going to equal each other. The parallel sides are, but the main thing here is that they have four right angles. So a rectangle could, if you were looking for examples, think about a long warehouse building that may have very long walls that are parallel to each other, but then the entrance and exit ends are shorter. But there you've got the four right triangles. And a square is a parallelogram that's got everything. It's got the four congruent sides and the four right angles. So make sure that you include these on as a definition. You'll probably be asked what the definition is and to draw it. So keep those in mind. The example number one, I'm not even going to go through. We're going to just skip to page 326, and we're going to take a look at some corollaries. And remember, one thing leads to another in geometry. We have postulates, and we have theorems, and we have corollaries. And so one thing leads to another is all I can say. They're all important. But the first information I gave you on the previous page was definitions, and here we have corollaries. And if you're like me, you want to know what things mean, well, you can look in your glossary, but a corollary is something that can be proven by a theorem. So let's take a look at these. We have the rhombus corollary. If a quadrilateral has four congruent sides, then it is a rhombus. So remember when we've talked, I'll present something to you and I'll say, okay, now we're going to do the backward. So I already gave you the definitions. This is kind of the backward to that. Here's our four congruent sides, and so we know that this is a rhombus. Here's the symbols for it if you like pictures like me. A rectangle corollary. If a quadrilateral has four right angles, then it is a rectangle. So we can look at this one, and DC and AB look like they equal each other. AD looks like it equals BC, but all those sides don't equal each other, but it does have the four right angles, making it a rectangle. And then finally, the square corollary, if a quadrilateral has 4 congruent sides and 4 right angles, then it is a square. So then they go on to show us that all of this information is true. So just like with triangles, now we have some things that we're able to use in proofs. And so hold on to that information. All right, now we are going to move to a couple of theorems. And this is about what happens to the diagonals in a rhombus. Now remember, the rhombus is kind of like a kite. We go out and fly the kite, or a diamond shape. But we are going to use its technical term, the rhombus. And the diagonals will form or will be perpendicular to one another. Now we also see that in this rhombus, 4 triangles are developed. And so remember, there's certain things that we could even learn about the triangles in this. But just for the purposes of teaching you the theorem, we have the 2 diagonals cutting from C to A and D to B. And when they come together, they are going to be perpendicular. And in a proof, then we could go even further and say that with those perpendicular diagonals, we now have 4 right angles. And then we could go on to say that those angles equal 90 degrees, all because of definitions that we've already learned. So remember, Theorem 6.10, diagonals of a rhombus, that's really all you would have to write. Diagonals of a rhombus, you could put the perpendicular symbol, and then I know that you know how to use that theorem. Theorem 6.11 is going to be the same thing. We're using the diagonals, not the same conclusion, but we are using the diagonals. And the diagonals in a rectangle are congruent. So what we learn here is that DB and AC are going to be equal in length. They're congruent, so don't forget that piece of information. All right, let's take a look at our checkpoints on page 328. So go ahead and turn to those checkpoints. And we want to take a look at them. Now, I've already put the answers up here for you, but let's talk through how we do this. So they want us to find the value of x in each of these pictures. And the first one they tell us is a rhombus. And so we know that when the diagonals cut down through the rhombus, and this one doesn't look very much like a kite, but that's okay, we know that each angle is going to be a right angle because these lines are perpendicular. Sorry, I just had something pop up on my screen. And we know that all right angles equal 90 degrees. So x is going to be 90 degrees here. Now in this one, they want us to find, or we have rectangle EFGH, that's given information, and they want us to find the value of x. Now we know that the diagonals in a rectangle are equal to each other. And I am not 100% sure if this means that EG equals 12 or E to the middle equals 12. Either, I think we're going to say EG equals 12. That would mean that HF is going to equal 12 as well, because we know that these two are congruent to one another. And finally, now we have a square, JKLM. And in that square, we have 2 diagonals, and we've learned about the rectangles, and they're going to be equal. But another thing that we've also learned is that in a square, all of our angles are equal, and we know that they're going to be right angles. So when these diagonals cut through that angle, then it leaves 45 degrees in each of those. So that's how we can make determinations about the angles on a square, on a rhombus, on a rectangle. And notice we do have triangles going on in here, so that could come into play very quickly. So always remember that your squares, your rectangles, and your rhombuses are going to produce triangles, and so there might be things that you need to remember from our triangle days. So that is all I have on rhombuses, rectangles, and squares. So take a jab at the homework, and on Wednesday, if you have any questions, I would be happy to answer them. And I will see you in tomorrow's video on trapezoids.